Hi everyone, welcome to another episode of my tutorials on Galaxy for Bioinformatics. In today's video, we are going to look at how to pour variants using FreeBayes on the Galaxy platform. So let's get started. Now, this video is based on this Galaxy tutorial. Let me show that first. This is a tutorial and this is a page, and I'll leave the link to this page in the description box. So in this tutorial, the authors showed how to perform exome sequencing data analysis for diagnosing a genetic disease. So this tutorial here includes a variant calling aspect, a variant calling step, and that is what we are going to reproduce in this video. All right, so I am not going to go into details with this entire tutorial. I am going to look at just the variant calling aspect. I will later make a tutorial where I look at this particular topic in its entirety. So I repeat, for this tutorial, we are going to look at the variant calling aspect. And let me also say that for those who are interested in learning how to run FreeBayes on the command line on the terminal, I have a tutorial on that. Actually, I have 2 tutorials on that. So if you are interested, you can check the description box. Sometimes it's advisable to use the command line, and sometimes it's advisable to use platforms like Galaxy. So sometimes people ask the question, Galaxy and then the command line, which is better? It depends on the situation. All right, so there could be situations where using the command line is appropriate. There could be situations where Galaxy is also appropriate. So this question can be answered on case by case situations. All right, so let's proceed. So make sure you have an internet connection and you also have an internet browser. So let's get started. So let's look at the content. So if you look at the content for this tutorial, we have data preparation, party control, read mapping, read, processing, and then variant calling. So we are following everything from 1 to 6. That's what we are going to do in this tutorial. All right. So you need to make sure that you visit the Galaxy platform. In this tutorial, I'm going to use the Galaxy EU platform because I realized that one is comparatively faster. I suspect the number of jobs on this platform is lower than the ones on the main Galaxy platform in the galaxy.org. So in this tutorial, I'm going to use this one, but you can use any of them. It's fine, whether Galaxy EU or Galaxy.org or Galaxy Australia or whatever country is available to you. Just use them. The tools work the same. All right. So I'll repeat, I will leave the link to this platform in the description box. All right. So just take note of that. So let's continue. So here, what you have to do is to first create a history. And before you even create a history, make sure that you have created an account and you have logged in. This will help you to save your data. It will also help you to save your sessions. All right. So after logging in, create a history, come to this side, click history. You have this coming up. Then you can edit this, and then you can just give it a name. Let's say variant calling. It's FreeBayes. I'll just do like this. Let me check something here. Yeah, I'll use the exact same spelling here. All right, so I will save it. So that's it done. Now, if you're a beginner, I will also encourage you to read the introduction because it's very, very important. It helps you to know the reasons why some of these things are done. So if you're a beginner in bioinformatics, it's important to read the introduction and then get an overview of what has been done or what has been done. All right, so just make sure to do that. All right, now let's continue. We still have some stuff to do. So let's do this. So when we take a look at the contents, first thing to do is data preparation. So let's get to this section. It's even here. I don't need to click. I'll just scroll down. So with the data preparation, what we are going to do is to import the data. And then we're also going to perform quality control. All right. And then we also do the mapping and stuff like that. But what we need to do first is to get the data. That's what we need to do. So we are going to get our reads, our FASTQ reads or FASTQ data. So they are here. These are the links. So we are going to import them. All right. So first of all, I'll just copy the links. And then I'll move to my Galaxy platform and I will come to this side upload data, this side here. I'll click it, and then I'll come to paste/fetch data. Okay, this one here, and then I'll come to this entry box and I will paste the links there like this. I mean, all of them. And then I'll click on start. All right, so that will activate the processes. So you should monitor the right side. Once you see the list of the files, then you can close this one here. Then you can wait for the files to get imported. That's what you have to do. So there's the first step that we have to do. Now let's wait for the data to be imported. Okay, the files have been imported, so we have them here. So we have 3 samples. All right, even though there's a total of 6 files, we have 3 samples because we are dealing with paired end reads. So we have father, mother, proband. Right, so these are the 3 samples. So we have I1, I2 for each of the samples, representing forward and then the reverse respectively. Right, so that's it. Now there's something else that we need to check. Now when we get back to this one here, this page here, okay, the original tutorial page, so check this one, tip importing violence. So click it, and it will tell you that when you are importing, you have to change your type to FASTQ sanga.gz. All right, we did not do it, but it doesn't matter, we will still check it here. So basically what this means is that we have to make sure that the data, okay, the type or the format is FASTQ sanga.gz. So we can do that here before we proceed. So just click on one of them, any of them. So let's say data 1, that's father I1. So click it and then check what is given here. So the format, you should see FASTQ sanga.gz. That's what it means. All right, so it should be fine. Once you see that the format is this one here, then it's fine. You can click on the others to check. I repeat, you can click on the others to check. That one is up to you. Here we are dealing with just a small number of samples, so you can manually check each of them, right? But everything's fine. If you have lots of samples, then you can do that setting, or you can check that setting when you are importing. We did not do it in this tutorial because I knew it will work fine, but just make sure to do that. Maybe another tutorial will show you how to do that, but for now, things are looking good. All right, now let's get back to our tutorial page. Let's look at the next activity. So let's scroll down. All right, let's scroll down. The next activity is to import the reference sequence. We have that here. Okay, so we need to import it. So we have to get a link which is here. So I'll highlight and then I'll copy it. And then this time I'm going to show you how to change your type. So here it says type is FASTA. Okay, and then genome, this is the information. Okay, so I'll just do that here. Okay, we have to upload and then probably do a renaming. Okay, I think we will still have to do renaming, it's fine. We'll just do it. Okay, so I'll just upload first. So I'll come to upload and I'll come to paste/fetch and then I'll paste the link there. And then here it says auto detect. So we say type is FASTA. So I'll just click it. You can also type and search for it. That's this one here. Okay, and then the genome, we click and we specify what was indicated. That is here. So it says human, February 2009, right? We'll just have to search for it. So I'll just type human. Now let me just say human, February. Yeah, so there's it. This one. So I'll just click it. So that's it. So now we can import. Let's just make sure everything is okay. Yeah, we can import it. So let's click on start. So once you click it, make sure that the progress bar is 100% and then check the right side. You should see the file name indicated. So we can see that here. So let's close this box and then wait for that to also get imported. Okay, the reference genome has been imported. Now there's something else we need to do. Let's get back to the tutorial page. So let's look at point number 10. It says rename the reference genome. So we have to rename it so that we get the format that the tutorial expects us to have. So let's get back to the platform and then let's rename the file. So look at the file, the reference genome. So to rename it, come to the right side. You see this pencil icon here, click it. And when you click it, you have to wait for the attributes to load. So when it loads, you will see this coming up, name, and then you'll see the name here. So what we have to do is to remove the .gz. These are the characters we have to remove. So this name here, we remove the .gz. So just clear the Z, clear the G, clear the A, and that is it. So now you can save the changes. Okay, so when you save it, it says attributes updated, and check the right side. You will find that the name has been changed. So instead of hd19chr.fa.gz, we now have hd19chr8.fa. That is what we want. All right, so now let's get back to the home page for our platform. Okay, so now we are here. Okay, so we are done. So let's get back to the tutorial page. And it says, congratulations, we are all set. So I also congratulate all of you for importing the dataset. Now we will proceed. So what we are going to do next is to perform quality control. So quality control helps us to identify possible issues with our data, and then we can resolve them before we perform the downstream analysis. All right. So it's always important to perform quality control. So just read this brief intro about quality control. I think it's going to be very helpful for beginners as well. All right. Now let's proceed. So with the quality control, we are going to run FastQC. So this will help us to assess the quality of the data. That's what we do first, and then we are going to aggregate with Multiqc. So for FastQC, I also have a tutorial on that. So if you are looking to run FastQC on the terminal, then I have a tutorial that shows you how to install FastQC and how to also run FastQC. So check the description, you'll find the link to that video. Actually, I have multiple videos on that, by the way. So let's proceed. So let's get back to the platform, and then let's check out tools. So come to the left side where you see tools, click it, search for FastQC. So I'll say FastQC, and then you will see it's coming up, FastQC read quality report. So click it, and then FastQC will be loaded for you. So when you are here, the raw data from your current history, come to this side where you see these buttons. There are 3 of them. So the first one, when you hover your cursor on it, it says single dataset. We have multiple files, and so we have to click on the multiple datasets. This one. So click it. When you click it, you have the files displayed for you. So you are likely to see 6 files because we have 6 FASTQ files here. So we need to select all of them. So what you have to do is to first click on data number 6. It will be highlighted, and then press your shift button on the keyboard. And then come to data number 1, the last one here, that's further R1. So click it, and then all of them will be selected for you. Okay, that's what you have to do. Let me just go over. So click on number 6, press the shift button, and then click on number 1. And then everything will be highlighted for you. Alternatively, you can click on one of them, press the control, and then click on the other ones as well. That also works. But the quickest way is to use the shift method, the one I just described for you. All right, so that is done. Let's check if there's something else we have to do with the FastQC. Let's see. Okay, so we have, it says, yeah, run FastQC. So we have to just call it and then select the tools. We have already done that. Okay, so everything is fine. So let's get back, and then let's click on the run tool, this one here. So you can click it here, or you can also click it here. All right, so let's click any of them. So click on run tool. So when you click it, on the right side, you are going to find lots of files generated, but you can differentiate them with the numbers, so that's fine. So what we have to do next is to wait for FastQC to complete its work, and then we can look at the outputs. Okay, FastQC has completed its work. So we have some files generated. For each FASTQ file, an HTML file we generated, that is this one here. So we have FastQC on data 1. That's for the data 1, the FastQ, all right? And then we have the web page. So this web page is an HTML file. And so you can open this file using your browser and then check the reports. You also have raw data, right? So the information here in the raw data, that is what is displayed when you open the HTML file. Okay, so for each file, for each FastQ file, 2 outputs will be generated. Okay, now if you have multiple files, like in our case, then going through these files, okay, going through the reports, all right, going through them one by one can be cumbersome. Okay, so the quickest way or a good way to view the report is to aggregate all of them together into a single document, and then you can read that document, or you can open that file using your browser and then read, check the reports, and even compare the files to each other. Okay, so what we are going to do is to aggregate the FastQC reports into a single HTML file, and we are going to use Multiqc. We are going to use Multiqc to do this. So in the next activity, we have to use Multiqc. We are going to use Multiqc to aggregate the FastQC results into a single file, and then we can open that file. But you can still download each of them and then check, okay, each of the HTML files and check and then explore. But I will skip that because the focus of this tutorial is on the variant calling, so I will spend less time on the examining of the QC reports. I have a dedicated tutorial for QC, so you can check the description book for it. And there's also a dedicated gallery tutorial for quality control, so you can also check the description. I have the link to that video, so check it and then just check it out. All right, so I'll proceed. So I am going to read the FastQC reports. Okay, so I'm going to put them in a single file using Multiqc. So let's get back to the gallery platform here. Let's come to the tools section, and this time let's clear what is there and then let's search for Multiqc. So we have that here. It says Multiqc aggregate result from bioinformatics analysis into a single report. So click it, and then the tool will be loaded for you. Okay, so when it loads for you, come to this side. So results, that's fine. Which tool was used to generate the logs? So here it says Samtools, but we are using FastQC. So click it and then select FastQC. So you can type FastQC, and when it comes up, you click it to select. Right. So once you do that, what you have to do is to click on this one here and set FastQC output. So click it, and then when you click it, you have this coming up. So here it says raw data. All right, that's what we are going to use, raw data. So make sure the option is raw data. And then when you come to this section, the FastQC outputs, make sure to select multiple data set. It should be highlighted, and you will see your outputs displayed for you. All right, so we are going to use the raw data. Let's check the gallery tutorial page to see what is there. So it says type of FastQC output raw data. We have specified that. And then FastQC output, all 6 raw data outputs of FastQC. That's what we are going to do next. Okay, so here you click on the raw data. So click on one, press the control, click on the other, click on the other one. All right, so you should have 3 raw data. Okay, as of now. And then come to the right side, click on the scroll bar, and then that will display the other raw data as well. So you click on this one, that's number 4. And then click on this one, that's number 5. And then let's go down to get the other one. That is this one. That is number 6. So you should have 6 raw data files, okay, because we have 6 FASTQ files and then 6 reports were generated. All right, so this is it. So once we have selected them, that is it. Let's check if there's something else to be added. I think that's it. So we'll also leave everything as they are now. So let's come back here and then let's click on run tool. So let's click it to run the tool. So once we do that, the report will be aggregated. So you are going to find 2 outputs generated here. At the moment, the background colors are gray, so that means that the job is good. So we have to wait for the background to turn green like this. Then that means that the job has been completed. Then we can explore. So let's wait for Galaxy to complete its work. Okay, Multiqc has completed its work. So we will have 2 outputs. So to view the report, you will have to use your browser to open the web page, which is this one here, right? So I'm going to download it. You can also download yours. So click it and then click on this one here, this save icon here. So click it and then save the file to an appropriate directory. All right. So I'm going to save mine now. So when you are saving, it will be saved as a zip file. So you have to save it and then extract the content. So I'll let the download get completed and then I'll extract the HTML file. Okay, so I am going to open it. It's done. Let me just do it here. I'll open the directory which has the file. This is it. So I'm going to extract the contents. Let's see. Yeah. So let me just extract the content. That is the HTML file. So there's it. So this has the report. So I'm going to open it now. You should also do same. Let's see. Okay. Okay, so we have opened the Multiqc report. So we have 6 files. So you are going to find 6 reports all aggregated into this document. So that's what you see here. So 1, 2, 3, 4, 5, 6. All right. So it goes for all the other statistics. So for this tutorial, I'll focus on just 2 of the statistics, and then I'll use that to explain a couple of things. So we'll also use the report to answer the questions that have been indicated here. We have 2 questions, so we'll look at them as well. Now let's get back here. So I will go straight to this one here, the sequence quality histograms. Now FastQC assigns 3 colors to the quality scores. All right. So that is what Multiqc also uses here. So if the line is within this region, the green region here, the top one here, that indicates high quality scores. Of course, the scores themselves are here, the numbers are here, and so you can also use that to track the scores. All right. So if it's here somehow good, and if it's here low quality, poor quality, the numbers also tell. Okay, so low quality scores. Okay, so without you having to use the numbers to make inferences, you can easily use the colors to help you get an overview. So that's a quick way to assess the quality. All right. So here we see that all the files, all the FASTQ files, they are in this region. So that indicates that they are all of good quality. That's what we see here. All right. But with Illumina reads, all right, with paired end reads, what happens is normally the qualities drop at the ends. And so that is why we see a drop at this side here. Okay. So it's something which is normal when you are dealing with Illumina reads. All right. And so what you can do is to trim those ends off. You can perform quality trimming, but that's something which is beyond the scope of this tutorial, but it's something you can also do to improve the quality. But overall, in general, the data looks good. And that is what has been explained here with question 1, the answer for question 1. That's what has been explained here. All right, so I just thought I'll do the explanation before I point that question out. And the question 2 also says, why do all samples show a non-normal GC content distribution? So let's get to that point, GC content distribution. So when you scroll down, you'll find that, let's check. So this is the GC content. All right, so let's get back to the question and then the description as well. I think that will help us. And so let's look at the question again. It says, why do all samples show a non-normal GC content distribution? And should you be worried? So here it says that a non-normal distribution, it's what we are supposed to see if you are dealing with whole genome sequence data. But for our data, it's a whole exome sequence. It's an exome sequence data. Let's put it that way. And so with exome sequence data, we will see a bimodal distribution. All right, and that is what we are seeing here. So with whole genome sequence, we are not supposed to see something like this. All right, but because we are dealing with exome sequence data, this observation is a characteristic of an exome sequence data. So even though the color here is red, which indicates something is wrong, this is actually an indication that we are dealing with exome sequence data. All right, so that's what you need to know about this particular one here. All right, so that is it for explanation. So that is it for the quality control. So I'm going to proceed to the read mapping section. Okay, so we are going to perform the read mapping. We are going to use BWA to do this. So the instructions for mapping have been given here. So we will use the reference genome we imported in addition to the FASTQ files we have. So that's what we need to do. So let's get back to the Galaxy platform. Okay, so we will now go to the tools section and then search for BWA. So we will use BWA mem. So I'll say BWA-mem. So you have two hits coming up. We will use this one, map with BWA-mem, this one here. Right, so click it and then it will be loaded for you. So it has been loaded. So we will need to follow the instructions that has been given here. All right. So first of all, we need to select a reference genome. So because we imported our data, we are going to use this option. Use a genome from history and build index. All right, so that is here. So here it says use a built-in genome index. We will change it. There's the reference genome section. So click it and then select use a genome from history and build index. That has been done. The next thing we have to do is to select the reference sequence itself, the reference genome, the file. So mine has been automatically been loaded. But if you don't see yours, click it and then select it. So you should select the AG19_CHR8.FA. Now let's scroll down to the other options. Let's get back to this page first. So single or paired end reads. So here we will select paired because we are dealing with paired end reads, and then we are also going to select the forward and reverse reads for the further data sets. We are starting with that one first, by the way. So just come to this side. Let's get back here. And then when we are here, all right, make sure it's paired, single or paired end reads. Click and then make sure it's paired. And then when you come to select first set of reads, there's this one here and this one here. So we are using the further. So here, make sure it's on single data set, and then when you come here, click and then select further. So further_1. And then after that, you will select the R2. So click and select further_2. That is it. And then after doing that, you will have to specify additional options. So we will scroll down to the read groups information. What we need to do has been indicated here. So here it says set read groups SAM/BAM specification. So we will do that here. So by default, it's do not set, but we will click and set it. So we'll use this one here, set read groups SAM/BAM specification. So click it and then you scroll down. So here it says auto assign. That is the read group identifier. It's no because we are going to specify our own ID or identifier. So that has been indicated here. So it says auto assign no read group identifier ID 000. So that is what we are also going to specify here 000. Now let's get back. Auto assign no read group sample name father. That is for the second one, which is this one here. So auto assign no and the read group sample name it's father, because we are dealing with the father reads. So this is this. The rest of the options we will leave them as it is because nothing else has been stated here. Okay, so that's how we do it. Now, on the command line tool, it's possible to set read groups. And if you're dealing with multiple samples, there's also a way to do it. And I have a tutorial on that. So if you're interested, you can check the description for that video. All right. I think that video is on my Patreon channel, but I'll leave the link there in case you want it together with the script. All right, so let's proceed. So everything has been done. So what we have to do is to click on run to. So we'll click on run to run it. So let's click it and then get BWMM to complete its work. Okay, so BWMM has started its work. So what we have to do is to wait for the mapping to get completed. Okay, BWMM has completed its work. So we have the output here. This is a BAM file. We have to repeat this for the other samples. I mean the mapping. We have to repeat the mapping step for the mother and then the proband, these other files. Okay, let me just get this. So we've already done father. So we have to also map the reads for mother and then proband. So that means we have to repeat everything here. So the instructions for doing that can be found here. So just scroll down a bit, you'll find them there. But that's what we are going to do. Instead of selecting BWMM here and then selecting all the options, what we are going to do is to rerun this one here. Okay, so click it and then come to this icon here, run job again. So click it and then BWMM will be loaded. Okay, now you don't have to worry. Okay, whatever we generate will be new outputs. Okay, so the current output will not be replaced. So if you're wondering if the current output will be replaced or deleted, no, it will not be deleted. Instead, new outputs will be generated. So using the run again strategy helps us to run the tools faster because we've already selected some of the options and we don't need to change them. Some of the options do not need to be changed. Okay, so when you rerun, those options you selected previously will be there and then you will change the ones that need to be changed. Okay, for example, the reference sequence or reference, we don't need to change it. So the only thing we are going to change is the FASTQ files and then the read group information. All right, so that's what we are going to do. So let's get back to the Galileo tutorial page. So for the next activity, we are going to map the mother sample reads to the reference sequence. So that is here. Okay. So when we come to this side, just scroll down, come to the read section, the section where we specify the reads. And then for further one, you click and change to mother one. That's mother R1. And then for the second set of reads for that R2, we change to mother R2. And then you scroll down to the read groups information. For the identifier, we will use 001 for mother, that is here. And so we will specify that here, so 001. And then for the sample name, it's going to be mother, obviously, so it's mother. And then all other options, we will leave them as they are, all right? So again, I repeat, the current data will not be replaced. inside we will generate a new output. Okay, so that's what you need to know. So that is it. So let's run the tool again to map the weight for the mother sample. So click run tool, and then let's wait for everything to get done for us. Please take note, this will take some time, and so you just have to be patient, probably more than 5 minutes. So you just have to wait. So let's wait for everything to get done for us. Okay, read mapping has been completed for mother, so that is also here. So father, mother, we are done. We are left with proband. So I'll click and rerun. Now you know the drill. So I'll rerun, then I'll scroll down to this side, mother, I'll change to proband R1. Mother R2, I'll change to proband R2. And then for the read groups, this is going to be 002, and then this is going to be proband. So let's check here. Let's make sure we are on the same page. Okay, yeah, so we have it. So 002 and then proband. Yeah, that's fine. So that's it. So let's run this. And then once we click on run to, everything is going to be done for us. So we have to wait for this mapping to also get completed. Okay. BWMM has completed its work. So we now have the map weight for all the samples. We have 3 samples. So we have them here. We have father, mother, and then proband. I repeat, we have father, mother, and then proband. These are the false. All right. Now you notice that the outputs are given numbers. Okay, but you can also rename them in case you want to keep track of the false. Maybe the numbers are confusing you, or maybe the text is confusing you. You can rename the outputs, okay, with the appropriate names or with the names of your choice. Let me put it that way. But for this tutorial, I'll skip them. I'll just use the numbers. So these are the samples. But I think it's better we rename it so that beginners don't get confused. So I'm going to rename them. So 25 is for father. I'll edit and rename it. So when you click the pencil icon here, when you click it, it comes here. All right. So here I'll rename it. I'll just put father here. I think that's better so that we can track it. So father, and then I'll save it. So you will see that the name has been changed. So we have father. Let's do for mother, which is this one here. So I'll edit and then also add the word mother to it. So let's wait for the edit attribute to load. So it's done. So I'll say mother. I'll save it. That has been done. Let's do for the proband. We should have done this before doing the mapping for the others, but anyway, that's fine. So I'll do for the proband as well. So what I also advise is that if you are doing the mapping, maybe in future you'll do some mapping activities. After doing the mapping, rename the output before you do the others. All right. Okay, now the proband attribute has shown up, so let's rename it. So I'll say proband. And then I'll save it. So that has also been done. So when you check the right side, you have the name there. So it becomes easy to locate them. So with the bound files, you can also download them. All right, so you can download them and then explore them and manipulate them later on. But for this too, I'll skip it because we are here to generate the final bound files. So let's click the gallery to get back to the home page. All right, so we are done with that. So let's go back to the tutorial page and then look at the next activity. So after mapping, what we have to do next is to process the reads. Okay, the outputs we generated, the BAM files, we have to process them. So in other words, we are going to look at mapped with post-processing. So you will do that here. So let's check what is here. It says at this point in the analysis, you should have obtained 3 mapped reads in BAM format. So each of these datasets should include a database set to the key HD19 and then any missing or wrong keys. Okay, we have to correct them. But I think everything is okay because when you click on the BAM file, any of them, you see database HD19. Okay, so once you click and you see format BAM database HD19, that means everything is okay. So no worries with that. So just do for the others and then make sure they are all the same. All right, so everything is okay on my side. So what about yours? Okay, so we are now going to process the BAM file. So we have some text here that you need to also read. It's important, especially for a beginner. And so the processing will help us to obtain high quality reads that we will use for the variant calling. So it's important to always do the processing. Okay, so processing will involve filtering and then also deduplicating the reads. So that means we are going to remove duplicates. Okay, so those are the things we will do here. Okay, so we will do those one before we use FreeBayes to call the variant. So the text has also been indicated here for us. So we will filter the paired end reads of all samples to retain only those reads for which both the forward and reverse reads have mapped to the reference genome. Okay, so they need to have mapped successfully to the reference genome. And then it says for such pairs of reads, we can be extra confident that they don't come from non-human contaminant DNA or represent a sequencing artifact of some sort. Okay, so this one here, we are dealing with paired end reads. And so ideally, what we should have are reads that map to the reference sequence. When I say reads, I'm referring to both the forward and reverse. Ideally, we should have both reads, the forward and reverse reads, mapping to the reference sequence. So that is what this function is about. So we are going to select the reads which have their mate pairs also mapping to the reference sequence. I've covered this step, this tutorial in another tutorial, in another video. I repeat, I've covered this step, filtering of reads. I've covered this particular filtering of reads step in another tutorial. So if you want details or if you want to use the command line tools to do that, you can check the description for that video. You can use Samtools. You can also use BAM tools for filtering of the reads, I mean the alignment records. What you should notice is that at this stage, okay, what we have are alignment records. Okay, so if you hear reads or if you hear alignment records, they are all referring to the BAM files, the entries or the records in the BAM files. All right. We also need to deduplicate the reads. So duplicate reads typically arise from PCR over amplification of genomic fragments during sequencing library preparation. Okay, so this can to some extent lead to wrong genotype assignments. Okay, so it's important to always remove the duplicate reads. Okay, so there's even one such situation here that you need to look at closely. All right, so it's always important to remove the duplicates. So with the removal of duplicates, you can use Samtools and you can also use the GATK suite, software suite to also do the duplicates reads remover. Okay, so you can do both. Of course, both tools have their strengths and weaknesses, so you will need to read the manual and then use the appropriate one. But for this tutorial, we are going to use Samtools, so take note of that. Okay, now let's proceed. We are going to do the filtering first, and then we are going to remove duplicates. Okay, we are going to remove duplicate reads. So let's start with the filtering. So let's get back to the Galaxy platform. We will use Samtools view. So come here and then search tools. Okay, so search, and you can see Samtools view. So this will give you the Samtools view tool, and then you can click it. And when you click it, you will have it displayed for you. Okay, the tool will be loaded. So here we are going to use BAM first. So come to this side, single data set. No, we are dealing with multiple data sets. So click it, and then all the BAM files will be indicated for you. So now you see the BAM files here. All right. So we notice that we renamed our respective BAM files, but even if you have not renamed it, that's fine. You will still see all the BAM files, and then you can just use that. Okay, so you can click and then select all 3 BAM files. Okay, that is it. What other options do we need to specify? Let's check. So for filters, it says exclude reads with any of the following flag sets. Read is unmapped, mate is unmapped. All right, so we will need to use that here. Let's check. Let's look at where that can be found. Let me just recheck again. So here it says configure filters. Yeah, so it's configure filters. But before we do that, let's take a look at what you have. So the Samtools view option, it says, what would you like to look at? So it says a filtered / subsample selection of rates. Okay, this one here. So we need to tackle that first. So what would you like to look at? That is here. So here it says all reads in the input data sets. That's not what we want. So click it and then select a filtered / subsample selection of reads. And then we need to configure the filters. So click it and then you can add your information. And that is what has been indicated here. So in configure filters, it says exclude reads with any of the following flags set. Read is unmapped, mate is unmapped. So let's check that. So we need to look at the exclude reads. Let's check. So exclude reads with any of the flag sets. So there's it. So click, and then you see some options coming up. So what you need to do is to select the ones that you want. Let's see. Yeah, so we have to select the ones that we want. Okay, so let's uncheck and then do something here. Let's see. So we've unchecked it. Make sure it's unchecked. And when it's unchecked, just click on this entry box here, this entry, this space here. So when you click it, you will see the flags being displayed for you. So you have to select the ones that have been indicated. So read is unmapped, that is one. And then mate is unmapped, that is another one. These are the flags we are going to exclude. All right, so just take note. So make sure to check and then select the appropriate flags. That's it. I think that is it. Let's check the documentation. Yeah, that is it. So we need to run it. So come to run to and then click on run. So when you click on run, Samtools view will do its way. So we have to wait. We are going to generate 3 outputs which are here, and then we'll proceed with the rest of the activities. Okay, Samtools view has completed its way. So we have the output here. You can rename them just as we did with the other ones, but for this way, I'll just leave them as they are. All right. So let's move on to the Galaxy tutorial page to look at what we're supposed to do next. Okay, so we are here. So what we are going to do next is to remove duplicate reads. We are going to use rmdup. All right. Please take note that rmdup is Samtools behind the scenes. So let's go to the Galaxy platform and then let's search for rmdup. So I'll search for it and it will show up, and then I'm going to click it. So once I click it, it's going to be displayed for me. All right, so there's it. So let's get to the tutorial page to look at the options we are supposed to select. So we are supposed to use the Samtools view outputs, and then we also need to indicate that the BAM is paired end. All right, and then the option treat as single, and you say no. So let's go to the platform again, and then let's do the selection. Okay, so let's do this. Let's pull up a bit. Perfect. So with the BAM files, because we are using three, we will need to specify multiple data sets. So when you click it, you have the BAM files shown for you. So we are using the Samtools view outputs. Okay, so we have to select all of them. There are three of them. So these are the ones. Okay. So that's it. Now let's move to the next option. That is this paired end or single data? We need to select BAM is paired end. If it's not there, click it and then select it, right? And then treat as single end is no. So that's it. Let's confirm. Okay, yeah, everything is fine here. So let's go back. Now let's run the tool. Okay, so I'll click on run tool, and once you do that, RM dupe will start its way. So let's wait for everything to get done for us. Okay, RM dupe has completed its work. So we have our output here, three of them. These are also BAM files. You can click and then check the format for any of the files. So you should see format BAM and the database AG19. All right. So you can check for the others as well. So make sure they all have the same format and the database is AG19. Okay. So just make sure to do that. Okay. So these are our final BAM files. All right. We've done all the processing. And now we have our final file. So these are the BAMs ready files. So what we are going to do next is to call variants. All right, and we are going to use these BAM files. These are going to be our inputs files. Let's get to the tutorial page to look at what we have to do. Okay, so let's scroll down a bit to the variant calling section. And I will encourage you to read this overview here. It's important, especially if you're a beginner. So try to read this overview here. That gives an overview of the variant calling process. Let's get to the main activity, and that is using FreeBayes to call our variant. A brief description of FreeBayes is also here, so I will encourage you to read it. It's important, especially if you're a beginner. I'll move to the practical itself. So we need to call FreeBayes and then specify some options as well as some inputs. So let's get to the Galaxy platform. Let's clear this. And then let's search for FreeBayes. So I'll say FreeBayes. So this is it. All right. So I'm going to click it. Okay, FreeBayes has been loaded for us. So we have it here. So we need to specify some options. Let's get back to the tutorial page and look at what we are supposed to do. So when we call FreeBayes, we need to choose the source for the reference genome. Here it says locally cached, but we are going to use a different option. Okay, I'll let you know when we are about to do that. And then for the run in batch mode, we are supposed to use merge output VCFs. And then we are supposed to also specify our BAM files, the RM dupe output. Now with the merge output VCFs, what will happen is that the variant identified for all the samples will be saved in a single VCF file. That means we are going to generate a single multi-sample VCF file. That's what we are going to generate. All right. And then for the reference genome, it says using reference genome human AG19. We will look at how to specify the reference genome. So there's not an issue. We will do that. Now let's get back to the platform. And then let's look at the reference sequence. So it says choose the source. So we will use history. So click it and select history because we have already imported our reference sequence, the FASTQ file. So we are using history. And then run in batch mode, we are going to use merge output VCF. So click it. Okay. So once you click it, you will have this coming up. Now, if you don't see any file display, let me just repeat again. If you don't see any file display, don't worry. Just come to this side. Click on browse datasets. So click it, and then you should see your lists, and then you can click and select them. So there are 3 of them, the RM dupe output. So once you do that, you can click on OK. Okay, and then everything will be fine. You should also make sure that you have selected multiple data sets. Okay, so make sure you have selected multiple data sets, and then if you don't see it, just come to browse data sets. Let me just click again. This one here, click it, and then your files will be displayed, and you can select the ones that you have. So RM dupe, this one, this another one, this another one. Use your control key, okay, to help you select the 3 files, and then you can click on OK. So once you do that, the files will be displayed for you, and then you can select the ones you want. So we are using the 3. So this, and then we select this, and we select this. So these are the 3 bound files we'll use. All right. For the reference sequence, we are using this one. We imported it, so it has been displayed. If you don't see it here, click and then select it. Okay. Now, what else do we need to specify? Let's get back to the tutorial page and see what we have to do. Let's see. Are we done? Let's check. Let's check. Okay, I think for this side we are done. Let's see. Yeah, we are done. Now, this one says limit variant calling to a set of region. Do not limit. All right, so we are going to call variant. We are going to check all the regions. So do not limit. It's already set. And then choose parameter selection level. Simple diploid. Okay. Simple diploid calling. This one here. So we will need to do that. It's already selected simple diploid calling. So we will leave it as it is. Now we are done. So what you have to do is to click on run to. So let's click it, and then FreeBayes will start its work. So let's wait for FreeBayes to complete its work. So you'll notice that one output has been indicated here. So this is going to be the final output. All right. So let's wait for everything to get done for us. Okay, FreeBayes has completed its work. So we have the output here. Okay, so this is a VCF file, right? It's a multi-sample VCF file. So this has the variant, and once you have it, you can download it. So you can just click and just save it. So I am going to save mine. So I'll save it here. I'll just save it. All right, this is a VCF file. So as for saving, you can also rename. All right, that's fine. And so once you generate your VCF, then it's time to perform the downstream analysis. Okay, and you also need to process the VCF. All right. So for example, in this tutorial, let me just check here. Okay, FreeBayes has completed its work. So we have the output here. There's it. So there's a VCF file. All right. So this VCF file, you can download it. So I'll just save mine. I'll just click and then save it. So I'll save it on my PC. And then I can perform some downstream analysis on it. Now this VCF file I have here is a raw VCF file. So further processing needs to be done before you can perform your downstream analysis. So in this tutorial, for example, what they did was to normalize the VCF file and then perform variant annotation and reporting. Okay. And so you can also do that, and you can also perform variant effect prediction using SNP EFF. There are things you can do, and I'm going to cover them in other tutorials. All right. And so if you're interested, you can also continue the tutorial, but I will continue it another time. Okay. And so for now, what I want to do is to practice how you can call variant with FreeBayes on a Aggregate platform, and then later we'll look at the rest of the analysis. If you also want to thank me. There are links in the description that you can use to buy me a coffee or tip me in proportion to how much you have learned. So I will see you in the next session.